Project Pro looks good. Okay, then down there, you choose which video camera you want, which is it your webcam or is it okay, so that's that camera.
Yes.
Okay. Cool, cool. It's gonna have to be your screen there behind you. So that's
Monday.
W1409. Here we go.
Yes, I'm not sure.
With the content.
Who is it exactly? Maybe I can Google this title. I think it's not this one.
Okay, school. I'll be back in a second.
Okay. 喂。
Yeah, open. Testing, testing.
Oh, okay.
We want,
Last speaker.
we want by magic. Presenter. Testing, testing. Testing, testing. And then we want, that's correct. Testing, testing, 1, 2, 1, 2. I can't see levels there though. 1, 2. Hey, hey. Hey, hey. We're recording. Hey, 2, 2. Hey, hey. Testing, 1, 2, 1, 2, 1, 2. Hey, we're sending. Yes, we are. 2, 2. That's that one there. I can see it. Can it? Or can it? It's up there. It's connected to representer, so that's correct. Testing, testing. Testing. Okay, so this actually that came up. That we don't want that. I think I just hit that by accident. Yeah. Okay. Cool. Testing. Okay, we got it here. Here it is. Here it is. Testing. 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 So we have audio. You have to mute yours. Correct. Is that our presenter up there?
Oh.
Oh, this we use yours?
Yeah,
Okay.
I think we can try, we'll have a try with yours. Yeah. Because we need to start back to. Just going to my phone.
这个摄像头它是没有的，是吧？那就是看观众，如果有人提问啊什么的，是只能有这一个是吧？
嗯，
只能看。
只能看这个。
那是哪一个电脑连到它上？
我的，就是插上去，它就连上。我刚刚试过。我现在要把我的电脑的声音给关了。
那个文件我们有吗？你刚才看的那个文件？
我不知道，我不知道你们这边有没有。
是什么？volunteer上我没有，是关。你是活动的学生？
嗯，
你是活动的学生吗？
不是，我是徐冠龙老师。
哦，关东什么时候回来？他回来吗？
他这次没回来，这次外考试。
他还会回来？
我就不知道了。
到时候你们这个电脑和我的电脑同时在线。我们刚才说，但是不能share屏幕。
或者 recording 就可以。就是我这个电脑是 record slides 后面
不是
的，，
如果就是说 present 是 in person 的话，那要用哪一个电脑？
用我的，用我这个，
啊，online 的话，他们如果也是像我这样看成这样的话，他们也不能 present 出来。假设说
不能
我现在
不能啊，只能有一个 video 录好的 video 给我。
video 不是 backup，
但是
不是 video 是 backup 吗？就是video 是生成到那个 OneDrive folder 里有一些，但是呢，那个是强制，不是说不行的情况下会把它放到，放到网上。
可以。
用你的电脑 share slides 吗？
对。如果说有第三个电脑的话，
但是 remote
就是我这个电脑把它
不是
设成那个 host，co-host，它就可以
那
share。
因为我们有一个 Keynote 是英国，一个 Keynote 是美国，那肯定要 remote，他们还没有到现场，所以
一个是吗？
第一个和第二个都是，第一个是英国，第二个是美国，然后他们可以被设为 co-host 吗？
可以的，只要把这个先登录进来，然后这边设置。
那你可以看他们在线，你这我看不到，人都看不到。
我也看不到，哦，这里。
Recording in progress.
啊，这个可以 share 是吧
嗯，
？OK，但我 share 没有用，他们 remote 那个，
他们应该可以 share。
都可以 share 的是吧
对，我这边。
？OK，
这个是不是？这个 decline。
啊，它不是 switch，那 switch 可能还没有到，那等它到了以后我跟你说一声。
好的，
我就觉得刚开始，
好的，好的。你们是没有线下的是吗？
有人在线下，有人在线上都可以，有人他是听众来不了。
好的，好的。
You send them the link on WeChat. Hey everyone, just waiting for the first keynote speaker to be able to join us online. Just one sec. All right. Thank you everyone for coming to this workshop. So on behalf of all co-organizers, we appreciate everyone's participation, and especially for those who submitted their papers and coming to present in person. So in this workshop, we'll focus on AI agent. As everyone would have known, this is one of the trending topic in AI. And particular focus of this workshop is for using AI agent for information retrieval. So our co-organizers, including Qingsong, Yongfeng, Zhiwei, Julian, Hua, Lindsay, myself, and Professor Philip Yu. We would like to thank the list of PC members who have helped us in assessing the submissions and accepting high quality submissions in the end. We are three keynote speakers, which we will introduce separately in the next few hours. We received quite a few submissions, and in the end, we decided to accept 8 of them. And they will be presenting their paper, some of them online due to visa issues, some of them in person today, this morning. So here's a brief agenda of today's workshop. In the first half session before the break, we'll have 2 keynote talks. And then after the break, we have another keynote talk, which is then followed by paper presentations. All right, without further ado, let me introduce our first keynote speaker. Our first keynote speaker is Professor Yue Feng. She's an assistant professor in the School of Computer Science at the University of Birmingham. Her research interests lie in NLP and information retrieval, especially in LLMs powered by AI agent, multimodal foundation models, and trustworthy AI. So is Professor Feng, can you hear me? I can see you online, but can you hear me? Hello? So they looks like they can't really proceed. Can you make her a co-host? And yeah, also him, also Zhibei co-host. Thank you.
Hi, hello, can you hear
All
me?
right. So Professor Feng, you should be able to present as a co-host.
Okay, let me share my
Are you
screen.
able to share slides and speak? You still can't do it. So yeah, we can see you, Professor Feng, on the screen, but you can't speak, can you?
Okay, can you see my screen?
So we should be able, you should be able to speak now, because if we can see you visually, we should be able to hear you audibly. So if you look at
Okay,
it
can
on
you see
the
my screen?
bottom
I
left
just
corner
share
of your
my
screen, if there's a audio that is muted, can you unmute that if that's the case?
I can hear you. I don't know why but in person meeting they cannot hear us.
Can you see my screen?
Hello?
Hello.
Yeah, that's weird.
Oh yeah, okay. All right, so what happens is that it is making a sound on my laptop, but not yours. So I probably just point the speaker to my laptop. No, it doesn't work.
Hello, can you hear me?
Yeah.
Okay.
Yeah, it seems online we can hear you, but I'm not sure in the meeting room whether they can hear us. Yeah.
Wait, can you hear? Can you hear us?
Yes, I can hear you.
Yeah. I'm checking with those attending in person.
We can hear you. Liu Wei, can you hear us? I think you are on mute, right? Hello? Wei?
Yes, I'm now opening my own laptop's mic. I'm just asking, where is the room's mic?
Okay.
And let's wait for them to.
Testing. Can you hear me?
Yeah, we can hear you, but it's kind of an echo.
Can
a
you hear
lot.
me?
Yeah.
Testing. So it's
Yeah.
coming through here. She should be able to hear me.
Yeah, we can hear you, I think.
And then the audio was on that machine, was it? Because that was coming out that machine. It should have been open here and closed up there. Yeah, the audio should be on. That's right. Can you go and close the audio on that machine, on your machine? It was. There's a speaker on the Zoom and we can't hear the audio.
Yeah, we can hear you.
Okay. Can you hear me?
Yeah. Can you hear?
So that's really like that. So it's coming out the laptop up there, and we want it coming out this laptop. It's Alex. So it should be coming through this machine. Yeah. And audio is open. Oh, it's open. Yes. Yep. And Black Magic external headphones, which is that was incorrect. That's what presented to there. So testing, and you can see it there. Testing. But it does the personal mic on. We can't hear them. We can't hear them.
Yeah, can someone online speak something?
Yeah. Can you hear us?
Hi.
Hello.
Hello.
Hello, can you hear us? Yeah, we are speaking. Can you hear us?
Hello.
I can hear you. Can you hear me?
Yes.
Yes.
Yeah.
Can you speak again?
Hello. Hi, hello, can you hear me?
You see, it feels like the online and offline are two different systems.
I don't know. Yeah, I'm sorry for people online. Can someone say something again?
Hello, can you hear me?
No, also my
Hello.
laptop. Okay, who said hello?
Hello.
Okay, I can hear you now. Good. Just one
Okay.
second. So what is this called in the list of speakers?
To the screen.
Retrieval.
What is this called? This one? Can someone say something again online?
Hello.
Hello.
Hello?
Hey.
How about now? Hello?
Hello.
Hmm.
Hello. Can you hear?
No, nothing.
Okay. Yeah, can someone say something now?
Hello.
Hello.
Where's my laptop?
Right.
No, where's? Okay. Can someone say something again?
Hello.
Hello.
They're good enough for everyone in the room or not? Yeah. Can someone speak louder?
Hello.
Hello. Hello. Can you hear? Wait.
Yes, we can. So what we're trying now is to use my laptop and just point the speaker to my laptop.
Mm-hmm.
That requires a bit of louder voice.
Yeah. Looks like it has echo.
Yeah, yes, it don't work. So lots of echoes.
You see the actual speaker.
What was the file that you have? Did they say anything?
No. I just set up all the things according to this instruction. And the back one is looks well and
Don't have anything to do.
So wait, can you hear us?
Yes, I can hear, but it's just on my laptop. The one on the in the room is not working.
Okay. So now it's from my side, I can hear very clearly. So looks like a lot of people there.
Yeah, we got a very good number of people here.
So Ziwei you might ask the professor from
Yeah, it's apparently
Columbia.
the problem is apparently that the list of speakers.
And the invited speakers we invited maybe need to
Yeah.
wait.
Yeah. Yeah, she probably joined maybe 5 p.m. Yeah, we can yeah, once she join we can let her know. Yeah.
I see a lot of people in the
Yeah,
room.
me too.
Hey, wait, you are on mute. Are you talking to us? I mean, cannot hear.
Yeah, can someone online speak something? Thank you.
Hello.
Hello,
Hi.
you can hear, right?
Oh, I think I can hear now.
Yeah, it's very clear.
Hello.
Yeah, I can hear you. Proof Yufen. Wait, can you hear us, right?
Can people online hear me?
Yes, we can hear.
Okay, thank you, everyone. Now let's get started. So, Professor Feng, sorry for the delay. Please go ahead.
So you can hear me?
Yes,
Uh,
we can hear you.
okay. Okay. Hello, everyone. I'm very happy to be here today, and today I'm going to introduce the conversational agents for information retrieval. And the search is shifting from the document to the dialogue. And here is an example. For example, some user wants to search the a question related to the Napoleonian, and then the user will ask, try to give some more details of this event. And the user also maybe ask about some more detailed questions. For example, it is whether related to the relevant to today. And from this example, we can see that the retrieval, there are some changes. In this example, we have the retrievers And we also have the language model to generate some feedback. And at the same time, we also need some conversational manager to manage the whole workflow. And all these different modules work together, and they can provide the users more better and more detailed retrieval information. And this is a conversational information retrieval in action. And here is a brief history of the conversational information retrieval. At the first, we have the neural sequence-to-sequence models, and the sequence-to-sequence models have the dialogue generation. And through this framework, we can provide some conversational information retrieval service. And then we have after that we have some question answering system, and also some machine reading comprehension method. And we can also use this kind of method to provide the conversational information retrieval. And in 2022, some dense retrieval method and also the RAG advanced method try to advance the retrieval service. And then we have the large language models. For example, the ChatGPT proves the large-scale conversational information retrieval. And now the large language model-based agent can better provide the information and also reshape the information access. And today we will introduce the 3 technical foundations. The first one is retrieval augmented generation, and the second one is tool learning in conversational information retrieval. And the third one is conversation manager in the conversational information retrieval. The first one is the retrieval augmented generation. Why do we need the retrieval augmented generation? Because the large language model's training data is frozen in time, and it makes the fresh information. And also the generation maybe have some hallucination problems, so we need the retrieval augmented generation. And also we need to improve the traceability, and also make the model become smaller and cheaper when we try to retrieval information. And at the same time, the domain adaptation on the fly is also important when we access the information. So plug in the previous document without fully fine-tuning is also very important. So the retrieval augmented generation is important in all applications. And here is a high-level pipeline for retrieval augmented generation. At first, we have the user query, and then we need to retrieve top K documents through embeddings or some information retrieval models. And then we need some augment prompt. We use the large language model and also the retrieval passages and also the user queries to prompt from the large language model, try to revise the generated information. And when we generate the answer, we need to stream with the citations and also use the retrieval document to generate the answer. And sometimes maybe we have some post-process. This is the high-level pipeline of the retrieval augmented generation. During this process, we need to make the retrieval information or generated context from the large language model without the hallucination problems, and also can try to make the whole conversation more fluent and also provide the user the information they want. So we also need the second technical foundations is tool learning. And here because the large language model have shown the promising ability, for example, in the context learning and also the real world planning. So to further increase the retrieval augmented generation ability, the tool learning task is also important when we try to get some external information. And here to integrate the large language model with the tools, most previous work represent the diverse tool call action as the special tokens, and also get the large language models by specific to tool use workflow. For example, in the figure, in this figure, the first in the figure A, and they first proposize the tool set into a unified structure by manually understanding the development documents of the tools. And based on the human expertise, the developers needs to elaborate the instructions and also give some few short examples. And however, these kind of methods, they usually suffer from two challenges. The first one is that it requires the intensive expertise to give the tool document and also create the examples. The second one is that the large language model shows the diminished performance when the in-context examples are incomplete or missing. And also, for example, when the AD hoc, it is a AD hoc to define the tool use workflow, and it's showing the limited generalization ability of the diverse tool utilization. And in the figure B, we can find this is an auto tool agent, and in this auto tool agent, it can it has two stages. The first is the tool encapsulation, and the second is tool programming. And through these two stages, the whole agent can outlearn how to use the tools and how to understand the tools. Here is an overview of this framework. In the first stage, the tool encapsulation stage, the auto tools can transform the tool set into a list of well-structured and also generated demonstrations, and also generate the demonstrations. And specifically for each tool, the large language model is provided with the raw document, and it also induced to encapsulate it into a function, and to verify the correctness. Besides some errors, the large language model is simulated to generate the function call, and at the same time, for each function, they can test the running time correctness. And since the relevant tool are typically from the same results, so showing strong input and output dependence. So we also propose an integration verification method, and this method can let the large language model to integrate relevant functions to generate the verification. And in the second stage, it is the programming stage, and the large language model is prompted to read the encapsulated functions and also flexibly integrates them into a unified programming language. And here we first load the encapsulated functions and initialize the execution environment. And then the large language model is equipped with the function library and try to generate the execution code, and use this code as a solution to call this tool. And the program call a chain of functions and frees useful intermediates to resolve the input and output dependencies among the functions. and by let the large language model as tool agent above, the auto tools can benefit from both the large language model's power and also can transform the tool document into the execution functions, and it can give better results. And here is the experiment results based on this pipeline. And from the results, we can see that the auto tool agent have the better performance. And here it achieves 89% in success rate. And here is some analysis experiment. We further explore the large language model's performance as maximal interaction turns from 1 to 5. And here is the results. We observe an increasing success rate from the 1 to 4 term, and it is also these results indicate that the large language model can correctly call the required tools and also revise the errors in about 3 steps. And we also analysis the efficiency of the framework compared to the some strong baselines. And from these results, we can see that the auto tool can consume fewer tokens compared to all baselines, and it can also achieving better performance. The reason we think that the large language model to integrate the well-encapsulated functions and also consolidate the multi-step tool learning actions into a structured program. So this method is more efficient. And the third technical function is the manager in the conversational agent. Here is an example of the conversational information seeking. And from the example, we can see that a user try to find some movie suggestions, and also combining the user's preference elicited through the conversational interactions. And the system can offer the desired recommendations easily. And the system can also answer the user's question about the recommendation, such as why to recommend the item and more information about the item. To develop more effective conversational information retrieval agents, there are some challenges. The first one is that the conversational agent need a dialogue manager, try to manage different subtasks, and also given the multiple subtasks are involved in the conversational agents, so the agent should also decide when to perform which subtask. And the second challenge is that the agent needs to proficiently address very different subtasks individually. And the conversational agents needs to design and optimize the specific subtask, allowing each subtask can achieve enhanced performance. And the third challenge is that the conversational information retrieval system needs to have better language generation abilities. And inspired by the recent advanced usage of the large language model for task planning, external tool using, and also generation, we propose a new framework based on the large language models, try to solve about challenges. And here is the framework of the method. It is a collaborative conversational information retrieval system, and it consists of a large language model as the manager, and also it has many different expert models. And the expert models and the large language model, they can cooperate together. And the workflow of this consists of 4 stages. The first one is subtask detection, and then the model matching, and the third step is the subtask execution, and the fourth step is the response generation. And in the first stage, the large language model first need to analyze the dialogue context and also detect which subtask we need to execute now. And then at the second stage, the large language model needs to distribute the detected subtask into suitable expert models. And in the third step, the expert models need to execute the assigned subtask, and also need to inference the results to the large language models. And at the last step, the large language model needs to summarize the execution information and also all the inference results and try to generate the response to the user. And here, this agent, they first use the schema-based instruction and also some demonstrations to instruct the large language models to understand the criteria for different subtasks. And in the model matching stage, this method also need to use a dynamic subtask and model matching mechanism to instruct the large language model to select the suitable expert models. And in the task execution stage, the large language model needs to select the suitable external models and also needs to call the external models. And at the fourth step, the response generation stage, the agent needs to use the summary-based generation to instruct the large language model to incorporate all the information from the previous stage and also from the expert models. And we also propose a fine-tuning method to try to make the whole agent can better answer users' initial query. And here we utilize the reinforcement learning from the performance feedback. And here the performance feedback include the first is the ranking performance. And the second one is the dialogue generation performance.
I'm sorry, Professor Feng. Because we started relatively late, if you can probably just simplify the rest of the talk, that we appreciate it. Thank you.
Okay. Okay. So this is the experiment for this framework, and we both evaluate the performance of the ranking and also the performance of the generated context. And from the performance, we can see that both at the document item ranking and also the dialogue generation, the performance is better than the previous baselines. This is the results for the dialogue generation. And from these results, we can see that the large language model-based method can significantly improve the performance of the diverse-based evaluation metric on the conversation. And it indicates that this kind of agent can keep the consistency with the ground truth dialogue, and it can also generate more diverse and informative response to the user. And here is a ablation study of this framework. We analysis the three factors. The first one is the usage of the subtask management, and the second one is the cooperation with the external expert models, and the third one is the usage of the reinforcement learning from the performance feedback. And from the results here, we can see that these three factors are all very effective for the overall agent. And here are some future research directions. For example, how to improve the reasoning and the tool use agents, and also how to solve the multimodal information retrieval problem, and also how to make the human and the agent collaborate together better. Okay, thanks for listening to the talk. Any questions?
Okay, thank you everyone. Because we started session relatively late, and we can probably accommodate only one question. Is there any question from the room or from people online? No? Okay. And again, I'm sorry, Professor Feng, that we started a little bit of technical issues in the beginning. Due to time constraint, we probably won't be able to have any questions because I think the audience are sort of still trying to figure out what questions they have from many of the questions they had. And myself also have many questions in my mind, but I probably just encourage everyone to have their questions to communicate offline with Professor Feng after the session. Okay, thank you, Professor Feng. So next we'll move to the second speaker. The second speaker is, I think, already online. Do you know how to enable the second speaker to be a co-host? Yes. So our second speaker is Professor Yu. Professor Yu is associate professor at the Computer Science Department, Columbia University. She's also co-founder of ArcLex.ai that centers its effort in harnessing the power of AI agents to empower and shape the future landscape of the workspace. She was featured on Forbes 30 Under 30 in Science in 2018. Her team also won the 2018 Amazon Alexa social bot competition. Her work on persuasive dialogue system also won ACL 2019 Best Paper nomination. So Professor Yu, can you hear me?
Are we able to invite Professor Zhou into the panelist? She's still in the attendee list.
So yeah.
So we
Wait.
invite. So Professor Yu, can you hear us, or can you typing something if you can hear us? We have invited you to be the co-host.
She's still in the attendee list. Are we able to invite her into the panelists?
Yeah, so can we add a
Yes,
prof?
can you hear me?
Yeah, we can hear you.
Okay, so we have already tried to add Professor Yu to a co-host many times. Professor Yu, can you hear? If you can you type in something in the chat?
Did it say accept the invitation? Looks like it is not able to type or. Zoe, can you ask her whether she can type?
Yeah, I'm asking her. Yeah.
Mm.
Is Dr. Zhuang here, by the way? Do you mind go first? Okay. So because our second speaker is still having technical issues, so we invite our third speaker to maybe swap the session. Thank you so much. So so our third speaker is an in-person speaker. So you probably use your own laptop, so we can probably squeeze a little bit. So yeah, so now our new second speaker now is Professor Zhuang. He's a postdoc researcher at the CSIRO, Australia eHealth Research Center, where he focuses on developing large language model-based search engine system in the medical domain. Before joining CSIRO, he was a PhD student at the IE Lab, the University of Queensland, supervised by Professor Guodui Zuko. His primary research interests lie in information retrieval, large language model-based neural rankers, and NLP in general. So, thank you.
I think we should record
So
this.
are you able
I think Professor Yu Zhou is online, so
Hello.
okay. I'm sorry about that. Yeah. So yeah, Professor Yu, great to have you here. Are you able to share your slides?
I think I joined the link from the Google invite. Is it a different invite?
Yeah, can you share your screen now?
Okay. I don't think I'm able to share my slides. Can you enable me to share slides?
So Professor, you can share your slides?
Yeah, I don't have a button that says share slides. I can only see like chat, raise hand, QA, transcript, show caption.
I think Professor Yu is still in the attendees, so she can talk, but she is not accepted. So Professor, Yu, did you see the invitation to join the panelist?
Let me see.
Yeah.
Mm. Oh, okay. Let me join this one.
Thank you.
It's a Google Meet.
Oh no, it's just
Oh,
a Zoom. It's just a Zoom. Yeah.
oh, it's a Zoom. Okay, let me see. I can rejoin.
Yeah. Is Professor Yu still online?
Yeah, she just rejoined to share, to get the permission to share. Yeah.
She's not. She's not. Somehow not here. Okay.
Are we able to invite the Professor Yu as a panelist? Oh yeah.
Okay, I think I can do it now.
Oh, great.
Right.
Okay, thank you, Professor Yu, and thank you everyone for your patience. So, Professor Yu, are you able to share slides now?
Yes.
Thank you.
And
So please get
nice.
started. Thank you everyone for your patience.
Okay, sorry about it. It's a little bit of technical difficulties. So today I mostly want to talk a little bit on AI agents, and specifically on AI agents that can learn over time. So I also have a startup called Arclex, which is commercializing the research that we have done in our Colombian natural language processing lab. So a little bit of background. So I've been working on AI agents for a long time, mostly on the algorithm side. And then I have a co-founder, Arbit, that most work on the back end of the AI agents stuff. So we still adopt the traditional AI agents idea that we have the environments and then we have the agents. Agents would interact with the environments through taking actions. And then the biggest difference than right now than before is that we have the chain of thoughts and all these kind of large language models ability to help people, mostly the agents, to be able to break down very complex tasks into individual steps and then perform actions to change the environments in order to perform various tasks like our booking of flights or coding agents and all these different kinds of values. If you think about AIs, before in an enterprise, people will buy softwares, and then the software distills all the industry best practice, and then people use this softwares to become more effective. And on the other side, right now, we're really thinking that the software is no longer a static thing. It's actually an AI agent that can actually perform services more autonomously. You can build AI agents for sales, AI agent for customer service, and these agents would talk to each other together with human agents to actually empower the enterprise in a more efficient way. So we're seeing like a software is becoming an agent that taking actions. It's a huge value add. We're not talking about that the AI agents are just the software spend anymore. AI agent could be an employee of yours. And then we have to look at the AI ecosystems. Nobody can do everything. I wanted to show you a little bit about what are different layers, for example, for AI agents. We have the foundational models. Specifically, we have OpenAI, Anthropic, Google, all working on foundational models. However, these foundational models are trained in terms of predicting next token. Is it a cat or is it a dog? So they're trained on static data. They're not able to perform action-based tasks. Well, what we have to do is really fine-tune these models and align them to be able to perform action-based tasks. So that's what we call agent foundation models. How do we do that? We could use reinforcement learning, continual learning, with the reward function that we design in order to improve these foundational models. So a lot of my research right now is focused on agent foundational models. We have actually a iClear paper called Exact, together with Microsoft Research, in designing for these VLMs, visual language models. How do we empower it to become a computer use or browser use agent that can perform various tasks more effectively, just leveraging the foundation model's power? So if you're interested, definitely read our paper in iClear 2025. You can find a lot of our papers on my websites. So later on, I'll also show you a couple of places that you can find me. And then on top of agent foundational models, we also wanted to make sure that we are not just using the brain, and we're actually leveraging the brain to be able to perform actions. So one thing is, for example, if you have a complex task, find the best red dress on Amazon, you have to use algorithms, or what we call orchestration layer, to break down these very complex tasks into individual steps, and then be able to call different tools or APIs in various different steps in order to process these actions. So this is why we have the orchestration layer to be able to break down tasks, to use the right tools, and also scaffolds or ML op tools to help you to make sure that the tools are doing exactly what you want. And finally, when we deploy these, we want to make sure that the agents are having the guardrails. So the agents are not actually performing things that you don't want it to do, such as having hate speech or any bad things that you never wanted to happen. Finally, we want to make sure that when you design these tools, design these agents, they're actually being able to meet what you want in terms of evaluation metrics, such as whether it's successful, is it actually doing the things effectively, is it being secure, not leaking your information. So the agent orchestration layer, you can think about our building blocks that people can use and reuse over time to build their own applications of agents. So this is what we think a very interesting area that for example, my startup Arclex is working on. And then once you have these building blocks, you can assemble them that actually work on design different vertical applications. For example, we can have AI agent, just one for product manager, AI product manager. You can have an AI software engineer. You can have an AI finance, AI lawyers, right? And for individual consumer apps, you could have AI for helping you to take notes, AI to help you to plan things, AI to as an executive secretary as well. So this is what we see as an ecosystem. And there are so many different opportunities left and right for different research and product. One thing that we really see that before, we have the simple automation where we say, you have this rule, if this happens, you do this. So if you're using any softwares before, like Canva has this kind of post scheduler, HubSpot also have these kind of scheduler for sending out emails. They're very rigid, but there are simple automations, or a lot of times people are using them for like these kind of RPA tools. While on the middle, with a large language model, we can actually make these kind of automation into AI workflows. So each individual steps are one prompt away of large language models. So they are connecting these prompt language model and various steps together into a workflow. But one of the biggest problems for this is you have to redefine these kind of workflows manually, which takes a lot of time. And also they're so rigid that if your best practice changes, you have to redesign them. So Zendesk is a perfect example. It's a customer service agent that can understand users, but your best practice on the customer service may change, and the maintenance is really high. While on the other side, which is we call it fully automated agent, like AutoGen, Cursor is one type of completely AI agents, which means that you can use natural language to describe what you want to do, and it would generate a bunch of code for you. But the problem with this is every time you have the same instruction, it may generate different block of code. So there's lack of consistency on that. But if you're human engineers, you'll be able to adjust them. But what if there's no human in the loop? Then AutoGen isn't really filling the task. So what my lab and my company is working on is trying to meet the LangGraph and AutoGen together, that we have a hybrid approach, that we still have a certain structure to guide your agents to perform so that your agent will be more efficient instead of searching the best practice every time, and again, getting more consistent. But at the same time, the agent would also evolve and learn through interactions with real humans in order to make sure that they are not a static graph, but a graph that can build and expand based on the utility. So if you think about how ArcLex work as a process, you first use natural language as an instruction. For example, let's build a Shopify agent to help you to sell products. You enter your name, the agent's like persona, enter what the agents are going to do, what is the best practice, and then give it available tools, for example, the product database, inventory management, so on. And then can automatically generate a task graph for you that actually completes all these kind of tasks, and also build in all these kind of back personas of your agent. And then because for every operations people, you want to make sure they're comfortable with the operations flows that you get. And for them, they usually cannot code. So how do we do this? We give them a Visual Studio type of adjustment. They can actually look at these code workflows, which is a JSON file, and visualize them, and then do drag and drop and edits to make sure that the flow works well. And they can test it exactly how the flow works on the side. So they can, for example, do product recommendation, give product as example, both vision and language is involved in this. And then you can also do like proactive promotions and so on. For example, this is one of the really great features people love about us. So we say, the agent will say, we currently have a promotion on this item. It is now get a second one for 50% off. And then the user will say, oh, that's great. Why don't you add another yellow one on the cart? So we can do resolvement in terms of resolution on what is yellow one. The yellow one means a cool boy basement hat. And then we'll be able to always check in terms of workflows that are there applicable discount or coupons. That you're only they're only $5 away from qualifying for free shipping. Want to add anything else, right? So in this way, you proactively reach out to the user, simulating how the best practice of a human sales agent in a store would do to be able to replicate the same bestseller over and over again with AI. So every customer that you're serving get the white glove service they never had before. So this way that you're actually interacting with a lot, you can deploy your agents in the wild, or you can deploy it within your salespeople to do beta testing. And then you'll be able to accumulate a lot of these, whether this person bought or whether this person did not buy. And then use that information as a reward signal to help you to refine your best practice in terms of workflow, and also put in the human element into it. So we know, oh, this person with this particular personas would actually prefer this type of recommendation, right? So that over time would also help you to be personalized and get more value add for individual users. So compared to a lot of existing framework, we're really looking into the ArcLex as a way that you are getting the intelligence through the interaction changes of the workflow, but we also have the workflow to explain what the agent is doing. So it helps you in terms of compliance, it helps you to align better with your operations teams. So this is a way that we see as a future that both accountable and also learning on the fly. So we're also having a open source version, so people can actually go to our website, arclex.ai, and select our open source version. Pips install ArcLex, every developer will be able to use our framework to build their own agents. So for example, we have various tutorials here that helps people to build their first agent. They can build an agent for a customer service application. They can build an agent for particularly, for example, booking service agent. Sometimes people use us to build various applications they use every day as well. For example, we have a developer build an agent to help them to select stocks every day. So they collect information from everywhere in terms of newspaper and do analysis and do comparison, and then finally do recommendations on stocks. So we really see that this is a way to democratize agent building. And everybody can build an agent coming with their own domain knowledge, and then really replicate your own unique ability through this agentic framework. So everybody else can also have an agent that carries your domain knowledge. So let's give you a couple of examples that we did that we find is really interesting. We deployed this interesting application. For example, if you're actually doing things, for example, apply for a car loan, you have to fill a long forms. And then a lot of times people just fill it in the middle and then just drop the forms. What can AI agent help is, instead of asking people to passively fill the form, you can ask questions that is missing in the database of this particular person. And then you can use very efficient ways of asking very useful questions to elicit information from the user. And the user just need to answer instead of thinking about how do I fill the form to reduce a cognitive load. If the user answered it incorrectly or in a way that we did not want, we can ask clarification questions. We're only asking questions that we think are essential to fill the form instead of asking the question from the form one-to-one. Because a lot of times there is an entailment that we can do to fill the form in a more accurate way. So in this way, by answering questions, you can get your form automatically filled. And you just need to review it one more time before you send it out automatically. This way, we can reduce the churn or abandonment of form filling by 40%. So you get more car loans application for everyone that could actually qualify for it, instead of they can reduce the friction of the film filling. Another one we did, for example, like Walmart. A lot of people would have questions about their product. For example, I'm buying a vacuum cleaner, but I don't know if how long the battery will last. If it's compatible with the filter that I bought just yesterday. Why is it $100 more expensive than the other vacuum cleaner in the same brand? I have all these questions for a considered purchase. Before, I would have to scroll down with all my user reviews of this particular product, flip through different pages to do the comparison side by side. Oh, I will have to go on Google to find Reddit posts to talk about this. It's a lot of time sink. And then sometimes I don't buy it on Walmart anymore. I actually linked it to Amazon, right? For Walmart, that's a bad thing. We wanted the customer to be on our webpage. We wanted to buy it with our webpage. So we can actually build an agent that supports this process by proactively showing you what are the frequent asked questions. And if that doesn't cover all the questions that you have, you can use natural language to ask questions. Just like what you would do with a customer service or salesperson within the store of Walmart. So that you're bringing this kind of sort of a physical experience of talking to a sales agent to online. In this way, we find like we get a lot of questions answered in this agent. The traffic is huge, and we find more people are happier with their purchase, and more people are buying this product because they know the product inside and out, and so that it can make a confident purchase. So in the same way, we also reduce the return because they know the product before they bought it, so fewer returns are made. So this is a huge success for e-commerce platform. So another comparable ones like Amazon has a Rufus, which is doing similar things as well. Any questions before I move on to a couple of other things?
Yeah, Professor Yu, please go ahead because we're running a little behind of time. So please feel free to go ahead.
Okay, so what I was wanted to talk about is looking into the agent frameworks, we're really seeing that we have this kind of enterprise cloud infrastructure, and then you're building onto, so you can accept all kinds of different models. Some of them would be good for a certain task. So you can orchestrate them together to fulfill different agent platform service. You can build recruiting agents, you can build a customer service agent, all kinds of different agents that share the same layer. So people can actually communicate in a more effective way. Due to time, like a limit, probably I'll just stop here. And so I wanted to also show you a couple of our interesting work in the end. Sorry, I have to go down to a couple of things. We have a couple of more papers if you'll be interested. Happy to talk more afterwards as well. So really recommended looking into the exact paper, Presto paper, and multiple prompts, soft prompts, controllable generation paper. Thank you.
All right, thank you, Professor Yu. Okay, any questions from the audience in the room or people online? Okay, okay, we have a question from Dr. Yeah, so go ahead. Can you hear the question, Professor Yu?
No, I can't really hear. If you can
Oh,
rephrase.
sorry. Can you hear now? Can you hear now?
I can hear you, but I don't know.
Yeah. My question is like you showed a slides of your Walmart example, and in your slide it says no AI hallucination. So my question is how you can guarantee this is the case.
Yeah, that's a really good question. We actually have a NARCO paper together with Warmer talking about how we actually make reduce hallucination. First of the things that we did is they have a product catalog that is stored in a data relationship database format. So we can translate natural language into SQL query and then query the information and then rewrite that attributes back into consistent conversations. So in this way, it's grounded to your relationship database. So they reduces hallucination that way. If you return something, for example, there's no return on the SQL database, then we say we don't know, right? We will have to contact a human agent for you. So in this way, that is more like constrained in terms of factuality.
Yep, thank you.
Thank you. Any other questions? All right, if not, thank you, Professor Yu. It's an excellent talk. We very appreciate that. So I guess there'll be more questions probably later on. So people feel free to contact Dr. Yu offline.
Yeah,
You can
so do to
raise
contact
one
me offline. We have a page, for example, for contacts. Yes.
All right. Thank you, everyone. So
Thank you.
Dr. Yu. So that's the end of the first half of the session. So the next half will start from 11. Thank you, everyone. I'll see you guys in about 15 minutes.